Hello, the goal of today's lesson is finding distance between points. Uh, and the success criteria, you'll know you've accomplished it when you're able to find the perimeter of a triangle that has these 3 points. So let's start from the beginning. Let's find the distance between the point 1, 1 and 4, 5. Now, there's 2 things to keep in mind, the horizontal distance and the vertical distance, and as the crow flies, straight across. What we're concerned about is this distance here. But in order to do it, we use the horizontal and vertical distance. Because these numbers are easy to find, the diagonal distance is more difficult to find. First, let's look at this. It has a distance of 1, 2, 3, and a vertical distance of 4. Now, since horizontal and vertical lines meet at 90 degrees, we can use an old theorem of ours, named Pythagorean's theorem, to find this third side. Pythagorean's theorem is a squared plus b squared is equal to c squared. So we'll use 3 squared plus 4 squared is equal to c squared. 3 squared is 3 times 3, which is 9. 4 squared is 4 times 4, which is 16. And now when you add them, you get 25. Now, in order to solve this, the opposite of squaring is square root. So if we take the square root of 25, we'll get down to 5. And now that is that distance on the third side. So that's 3, that's 4. This distance is 5. All right, let's try another one. Using the same method, and if you understand this, try to do this on your own. Pause the video. If I go 2 to the left and 1 up, and 4 to the right and 3 down, let's find the distance between these 2 points. Well, in order to do this, we need the vertical distance and the horizontal distance. So this vertical distance is 1, 2, 3, 4. The horizontal distance is 2 plus 4, which is 6. And now we want to find this hypotenuse. So 4 squared plus 6 squared will be my c squared, and c is that distance. So I square both those numbers and add them up to get to 52. And now I take the square root of 52, and that doesn't give me a nice number. So I'll take my trusty calculator out and type in the square root of 52, and I get 7.211 something. 7.2 is good enough. So that's 4 and 6. This distance is 7.2. All right. Now let's look and see if there's any shortcuts. So let's look back at this problem. If I have 2 and 4, negative 2 and 4, how would I get 6? And if I have 1 and negative 3, how would I get 4? Hopefully, you're screaming that that is subtraction. So if I take 4 minus negative 2, I get 6. Negative 3 minus 1, I get 4. 4 going down is still a distance of 4. So that's how we get those numbers. And now once we have them, we just square them, add them up, and square root them. So we could come up with a formula that looks like this. This is our distance formula. We subtract our x's, square them, subtract our y's and square them, add them up, and square root them. Hopefully you can see that this is really a squared plus b squared, and then c squared, we square root it after that to get that. So it's just the Pythagorean theorem. All right, now let's try to do this problem. Now there's 2 methods. I do not like to use the distance formula. I don't use it when I solve these problems, and so I don't expect you to. So what I do is I think about what is the distance between negative 1 and 2, or 1 and negative 2. Horizontally, it's a distance of 3. Now I focus on 5 and 9. Between 5 and 9, that's a distance of 4. And once you have that, then you can just use Pythagorean theorem to find out. This is kind of like the same one we did earlier. And our distance is 5. Now if we use the distance formula, which some people prefer the distance formula over my method, do whatever you think works best. So distance formula, we take x2, which is negative 2, minus 1, square it, plus y2 minus y1, and square it. So our distance is negative 3 squared plus 4 squared. Now negative 3 squared is 9. 9 plus 16, which is square root of 25. Square root of 25 is 5. So feel free to do either method. You'll get the same answer. Find the distance between negative 23 and 25, 27. You can do either method. Pause the video and see if you can do it on your own. All right, hopefully you're done. From 19 to 25, that moves over a distance of 6. From negative 23 to negative 27, that has a distance of 4. Now we just use Pythagorean theorem to find that answer. So the square root of 52 is, like we did earlier, 7.21. Now to do it the other way, we're going to take 25 minus 19 squared plus 27 minus negative 23 squared. That turns to a positive, and so this would be, that's a 19. So that's 6 squared plus 4 squared, or negative 4 squared, I should say. And that's going to be 36 plus 16, which is 52, which again is 7.2. All right, try this one on your own and see if you get the answer. That's 6 to the right, 5 up. So the distance between them is 5 squared plus 6 squared equals c squared. And so that's 25 plus 36, which is what, 61. So we'll take the square root of 61, which is 7.8. All right. Now we need to, our goal is to find perimeters of objects. This one is, we're going to go back to some elementary perimeter problems. To find the perimeter, that's the distance around an object. So 8 plus 7 plus 6, that's 15 plus 6, that's 21 centimeters. This rectangle, the opposite sides are 2's and 8's. So if we add them up, that's 16 plus 4, which is 20 centimeters. So hopefully you remember what the word perimeter means. So now when I find the perimeter of this object, that's the distance along the 3 sides. In order to do this, what we have to do is find the distance of each side. So AB, the distance from A to B, is going to be from negative 4 to 4 is 8, from 3 to 7 is 4. So I'm just going to do 4 squared plus 8 squared is equal to c squared, or 16 plus 64 is 70, 80. And now I take the square root of 80, which is going to be really close to 9, 8.94. So let's say 8.9. That's my C. Now the next thing, let's do B to C. Now I just did a quick drawing onto the side. Since this is graphed here, from B to C, we could also just use the diagram that we have. I go 1, 2, 3, 4 to the right, and let's move 1, 2, 3, 4, 5, 6, 7, 8 down, 4 and 8. So that's 4 squared plus 8 squared equals c squared. And since these are already here, let's just use that as proof that c will be 8.9. Now our last value goes from A to C. That's again 4 down, but now we're going 12 units across. So I'm going to say 4 squared plus 12 squared is equal to c squared. 16 plus 144 equals c squared. That is 160. So now if I take the square root of 160, I get C is 12.6. Now we're not done yet. We have these three values. The parameter is if this is 12.6, 8.9, and 8.9, we just have to add them up. So the perimeter, we add up those three values, 8.9 plus 8.9 plus 12.6, and I get 30.4. All right, so that's the distance around my triangle. All right, try this one on your own and see how well you do. All right, hopefully you're done. Now, the distance from A to B is going to be on a straight line, so it's 1, 2, 3, 4, 5, 6. So we don't even have to use Pythagorean theorem because it's vertical distance. 6 is all we have to do. From AC or CA, we're going to go over and down. We went 1, 2, 3, 4, and 1, 2, 3, 4, 5, 6, 7, 8, 9. And so we do 4 squared plus 9 squared is equal to C squared. And so this is 97. If I square root 97, it's going to be something close, little under 10. And I put it in my calculator, 9.8. So 9.8 is this distance here. So let's pick another color. Do green. Go over and up. Here we're going up 2, and that distance is again 9. So from B to C, I'm going to have 9 squared plus 2 squared equals C squared. Or 81 plus 4, that's 85. And when I square root 85, I get 9.2. All right, so now I have my three values. And now I just have to add them together. 9.2 plus 9.8 plus 6 gives us 25. So my perimeter equals 25. All right, hopefully you understood this video. And now you can do your homework.